Today we're going to talk about energy work calculations. Now it looks kind of scary because of all of the math and the long formula that's involved, but if you take it step by step, if you keep your numbers straight and organized, you're going to see it's kind of easy and it all makes sense. So our problem today is a glider is gliding through the air at a height of 400 meters with a speed of 20 meters per second. The glider dives to a height of 100 meters. We're going to determine the glider's new speed. So let's look at what we know. Well, we know that it's at a height, our initial height, of 400 meters. We know that its initial velocity is 20 meters per second. It's going to dive to a height of 100 meters. That's our final height. And we're looking for its new speed or its final speed. So the final velocity is something in meters per second. Now we have to go look at our formula and figure out what's at play. Well, we know we've got initial kinetic energy because it's moving through the air. We know that there is initial potential energy because it's off the ground. However, we can get rid of work. Work in this problem is a conservative force, the key word being gliding. It's working on gravity, and gravity is a conservative force. We know that at the end we have kinetic energy because it's still moving, and we're going to be looking for that speed. And of course it's off the ground, so we can't cross out potential energy. So we're going to plug in our formulas. Kinetic energy is 1/2 the mass times velocity squared. To that, we're going to add our mass times our gravity times our height initial. And that is going to equal our final kinetic energy, 1/2 the mass times velocity squared, plus the mass times the gravity times the height final. I like to make my math as easy as possible. So I'm going to look and say, what term can I cross out that's in each one of those? Mass, 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 and mass. So let's get rid of it. If we divide each one of these terms by m, we're going to make our math much simpler. So right now I'm working with less variables and I can plug these in. So I'm going to have 1/2 my initial velocity, which was 20 meters, squared. And to that I'm going to add gravity, which is always 9.8 meters per second squared here on Earth, times my initial height, which is 400. And to that, that's going to equal 1/2 my velocity squared, which I'm looking for, plus 9.8 my gravity times my final height, which is 100. When we do the math, 20 squared is 400. 1/2 400 is 200. To that I'm going to add 400 times 9.8, which is 3,920, equals 1/2 velocity squared, plus when you multiply 9.8 times 100, you're going to get 980. And now we're going to look to see where we can do the math and combine like terms. 200 plus 3,920 is 4,120. That equals 1/2 velocity squared plus 980. Looking at the problem now, I know that I have to get all of my numbers on one side and my variable over here. So I'm going to subtract 980 from each side. And on this side I'm left with 1/2 the velocity squared, and on this side I'm left with 3,140. I'm going to have to multiply now by 2 to cancel over here. Do the same thing on this side of the equation to get 6,280 equals velocity squared. Take the square root, and 79.2 meters per second will equal my new velocity. Keep your column straight, look for where you can find your numbers, cancel wherever. Yes, it's a lot of math, but if you keep it all structured and organized, you can make it easy.